All right. Today we're practicing special cases of and or compound inequality stuff. So let's talk about and that ends up being like one-sided. So like if we have x is less than 4 and x is less than or equal to 2, remember that and is only where they overlap. So if I have, let's do 4, 2. So if x is less than 4, that would be an open circle on 4 pointing this way, right? And then x is less than 2, I would have a closed circle on 2 pointing that way. Now where do they overlap? They overlap, we'll use the rainbow pen. They overlap from 2 to the left. So technically this would just end up being x is less than or equal to 2. And our interval notation would be from negative infinity to 2 with a bracket. All right, let's take a look at another one. So here's an and that has no solution. Remember, and is only overlap. So x is greater than 4, so let's go to that 4, open circle, pointing to the right. 2 is less than or equal to negative 2, so let's make this negative 2, pointing to the left. There's no overlap, so this would be no solution. All right, that's an example of a no solution, and you're looking for overlap. All right, let's take a look at an or that's one-sided. So or is everything. Everywhere the graph touches, it is the solution. So I'm going to just do everything in rainbow, because rainbow is going to count as our answer. So we have x is less than or equal to 2. So here's 2. We're going to do a closed dot on 2, and it's everything to the left. And then x is less than negative 3. Let's call this negative 3, and it's everything to the left. Well, this ends up just being this inequality, because that includes the x is less than negative 3. We care about everything, everywhere the rainbow touches. It's fabulous. It's definitely part of the answer. So this is everything. Lots of exclamation points. So this interval notation ends up being from negative infinity all the way to 2. I should probably go back and do the interval notation for this one. Oh. There is no interval notation. The interval notation is the no solution symbol. I forgot. Alright. Now let's look at or that ends up covering the entire graph. And again, I'm going to do this in rainbow so you can see that it covers everything. Alright, so if x is less than or equal to 2, let's make this 2. Let's close dot on 2. It's pointing to the left. Everything to the left. And let's say this is negative 3. I know it's not far enough apart, but just stay with me. So here's negative 3. I have an open dot. And this is everything to the right. And because this is everywhere the rainbow touches, it's the entire line. Interval notation here is my favorite. It is negative infinity to positive infinity. It is the entire dang line. It is most convenient, really. Alright, so let's practice a couple and see if we can determine what kind of answer it is. So first off, this first one is an or. So I'm going to do it in the rainbow pen, because everywhere the rainbow pen touches is part of the answer. So here we have 5x minus 3 is less than 12. The other equation we have is 4x minus 7 is greater than or equal to negative 47. Alright, so on the left side we're going to add 3 to both sides. And they end up with 5x is less than 15. So now we're going to divide both sides by 5. And x is less than 3. So I'm going to go to 3. And it's going to be pointing to the left. Now remember, everything in rainbow, everything the rainbow touches is part of the solution. Alright, so on this side we're going to add 7 to both sides. And I get 4x is greater than or equal to negative 40. I'm going to divide both sides by 4. Now remember, we're dividing by positive, so nothing changes. X is less than or equal to negative 10. So that would be over here. Solid dot pointing to the left. And that's included. So we only really needed this first one. We've got x is less than 3. So this is from negative infinity all the way to 3. It's an open circle, so it's a parenthesis. That is our solution. All right, let's go ahead and try this other OR. Again, I'm going to do it in the rainbow pen because everything the rainbow touches is part of our solution. So we've got 9x minus 9 is greater than or equal to 0. And our other equation is 10x plus 10 is less than or equal to 70. All right, let's start with the left one. I'm going to add 9 to both sides. 0 plus 9 is 9, so we have negative 9x is greater than or equal to 9. Divide both sides by negative 9. And I have x, and I divided both sides by negative, so I have to flip my inequality, so x is less than or equal to negative 1. So this is a filled in dot on negative 1, pointing to the left. Okay, and on the right, I'm going to subtract 10 from both sides. And I have 10x is less than or equal to 60. And I divide both sides by 10. And I get x is less than or equal to 6. So this will be a filled in dot on 6, pointing to the left. And because it's everything the rainbow touches, the 6 includes the negative 1. So this is going to be from negative infinity to 6 with a bracket. And it's going to be that one. That would be the only inequality we would have to write for a solution. All right, let's do a couple of and ones. So we've got this one in the middle. Got 10. And we're going to do this one with red because it's only overlap. So I've got 10 is less than or equal to 4n plus 6 is less than negative 26. I'm going to subtract 6 from all three sides. On the left, oh, I see a problem right now. Do you see a problem? I'm going to highlight a problem that I see. I'm going to point it out when we finish solving. All right, so we've got 4 is less than or equal to 4n is less than negative 32. Now we're going to divide all three sides by 4. And I get 1 is less than or equal to n is less than negative 8. Now this is where it's important. Is 1 less than negative 8? No. So that was fun. Our interval notation is no solution. And our graph is already done for us. It's beautiful and not colored in. Well, that was quite fabulous. All right, let's try this one over here. We're going to do this one in blue. So this one, we're going to have to treat it like two problems. Notice the word and. We are only looking for overlap. So we have 9k plus 2 is less than negative 61. And 6k minus 2 is less than or equal to 28. So I subtract 2 from both sides. And I get 9k is less than negative 63. And I divide both sides by 9. And I get k is less than negative 7. So I'm going to go to negative 7, open dot, pointing to the left. Now because it's only overlap, I'm going to switch colors so I can see this a little better. Yeah, we'll go with red. So here we're going to add 2 to both sides. I get 6k is less than or equal to 30. Divide both sides by 6. And I get k is less than or equal to 5. I'm going to go to the 5, which is over here, and it's everything. So it's a filled in dot on 5, everything to the left. And we only want overlap. So the only part we care about is from here to the left, because that is the only place, so I'll do it in rainbow, from here to the left, because that is the only place they overlap. So that is k is less than negative 7. That is from negative infinity to negative 7. That's the only place they overlap, is everything less than negative 7. All right, I want you guys to go ahead and give these two a shot, see what you get, give it your best shot, and give these two a shot, see what happens. You got this. All right, and I'll see you guys next time.